We're right on time. Good for us. A time conference, how strange. It's my pleasure now to introduce Gil Biran from Oscilloquartz. And Gil is going to talk about something that has actually to do with your market, about time, right? It's pragmatic approaches to sync delivery and finance markets. And the next couple of speakers are actually going to talk about the finance industry specifically. It only took us all day to get here. Gil?
Good afternoon. So I'm going to talk about how we are going to solve the problem. We talked about what is the problem and why we need to solve it, but I'm going to talk about how. So who knows what this accuracy means? This is picosecond, okay? Talk about nano, micro, this is a picosecond. I'm not saying that we are running in picosecond rate, but with all this requirement about synchronization, we need to move much faster. Maybe in minutes or hours or days, not pico, but we are going more and more to accurate solutions. So why we need accuracy in the finance market? First of all, it's about accurate financial reporting. Okay, we need to know what we are doing. What exactly is the time of the events when we are doing machine to machine, for example. We need to eliminate fraud and assure that every trade will be secure. And one of the ways to know what is going on is to know exactly what was the time that it happened. Then we need to protect the customers behind the transactions. And if we make sure that there is no manipulation of the time, it's another way to secure the transactions. Of course, there are a million other ways. And the last one is to ensure the security of cardholder data, online transactions, and such. So, looking into the reasons why this room is full and why next month the MiFID II conference in London is already sold out as well, is because of regulation. So we are talking about time in finance market for many, many years. And we didn't see any change. It was more of the same, NTP-based, and nobody had a good reason to basically make any change. And this is changing now. It is changing because of the SEC Rule 613, which is about in a nutshell, 100 microsecond time stamping requirement. And this is about the equivalent of SEC, the ESMA, in Europe. And in their case, it's the regularity technical standard RTS 25. Originally, it used to be called RTS 36, but in September 2015, they changed the spec number from 36 to 25. So don't get confused about this. And they call it MiFID II. The requirement around MiFID II is more strict. Here we're talking about 1 microsecond. So the main reason why we are discussing this today is because of these two sets of regulations, which are coming into play early 2018. I believe that the MiFID date is January 14, 2018. I'm not sure what is the date about the 613, but I believe it's about the same time. On top of that, there is a requirement that was always there, but I assume that nobody has the justification just for this application to spend the money to make the change. And this is about algo trading, machine-to-machine, high-frequency trading, the need to improve the algorithms. In order to improve the algorithms, you need to make sure that you have the record of all the transactions, and it has to be very accurate. Here we're talking about 1 microsecond at least, because then the engineers that develop the algorithm can look back and see how they can improve their algorithm. So this is additional requirement, but the last requirement was there for many years. Together with the first two, I believe that it's going to happen much faster. So I think Richard mentioned time as a service. Of course, there are two approaches here. The first one is each one of financial organization can go and build his own network. There are advantages and disadvantages of this approach. But there is another way of doing it. And the other way of doing it is for the operators to start selling time as a service. Time as a service is out there for many years. Actually, ATIS defined specification for this already a few years ago, but we were between mobile operators that waiting for the wireline operator to provide the services, and the wireline operator saying we are not going to spend the money because the mobile operators are not interested in our service. And I heard both stories from both sides, okay? And this is going to change because in the mobile market, the requirement is keep changing. The standards today are about 1.1 microsecond in the air interface, but in 5G, in 3GPP, we are already discussing 65 nanosecond, 130 nanosecond, 260 nanosecond. Thanks God for you in the finance market, I'm not aware of any requirement on top of the 1 microsecond, okay? But because the operator must deliver time as a service, first of all, for the mobile operator, because over there, it's an infinite race. You didn't even deploy yet 1.1 microsecond, you already have to design your next step, which is 260, 65, different scenario. So the operators are doing this job mainly for the sake of the mobile operators. You can get advantage of this investment by buying this type of services from these operators. And I'm sure you understand what there is for the operators. It's basically selling another services, not just selling pipes by the megabit per second, but also sell some added value services, and this is the synchronization. So what is the problem that we are trying to solve? So this is a typical network today. You have NTP server on one side, and you have NTP client on the other side. And yes, if the NTP server is in the same room as the NTP client, life is good. But in reality, it can be very far away. It can be 5 hops away. By the way, it doesn't matter what is the physical distance. It's not about the physical distance. It is about how many hops, how many network nodes you have between the NTP server and the NTP client. And it could be 5, it could be 10, it could be 25. And here's the problem. NTP was never designed to deliver this level of accuracy over network with many, many hops in between. NTP does not have boundary clock function like PTP. NTP does not have transparent clock function like NTP. And these functions are being used today in order to improve the packet delay variation and the asymmetry of the network. So clearly, keep using NTP all the way is no-go. However, going and replace all the NTP clients out there, and we're talking about millions. You can look online how many numbers. We're talking about the number of clients is 50 million and more, and it's keep growing. To replace every NTP NIC device out there or NTP client out there, it's not realistic at all. So we need to look for a pragmatic solution. And the pragmatic solution is to leverage the PTP deployment that is done, first of all, for different reasons, in order to deliver the accuracy while maintaining NTP in order to deliver the time. Basically, time of day will going to be delivered by NTP because there is no issue here while the accuracy of the 1 microsecond can be provided by the PTP. So basically, what we need some mediation between the PTP and the NTP. And of course, this mediator, not the PTP, NTP server anymore, or the PTP grandmaster anymore, need to be as close as possible as the NTP. And I'm going to show you once again different scenarios. Now, of course, as you can see here, between the PTP grandmaster and the PTP to NTP converter or mediator, you have boundary clock, transparent clock, and such. So you leverage on the strengths of the PTP technology in order to deliver the 1 microsecond as close as possible to your client. So let's zoom in how it looks more in details. So on the right side, you see the PTP part. Standard PTP part, nothing special. And then you need to translate from PTP to NTP. So you need a device that can convert PTP to NTP, and on top of that can deliver 1 PPS signal, and then the NTP will use in the NTP NIC for the time of day, while the 1 PPS signal with better accuracy will strobe the NIC in order to deliver the 1 microsecond accuracy. So what we are doing here, we are gaining from both worlds. We are taking the advantage of NTP as existing solution, low-cost solution, the deliver time without the accuracy, and we add on top of that PTP to deliver the accuracy. Of course, you can go and replace everything to PTP. I'm going to be happy, but most likely you as a customer is going to be unhappy. And if you want to have a win-win solution, this one can work much better. So this is a real case from a market that we did recently. So you can see here you have NTP data logger and NTP time loggers and trading terminal and the database loggers. They are all NTP. Of course, the customer could go and replace all of them to support PTP. But why? Instead of this, he is using PTP input, convert it to NTP to maintain the time, and deliver the 1 PPS locally to any one of these devices. Of course, the distance, the physical distance between this device and the end device need to be short. First of all, in order to maintain the NTP impairment low, and the second reason, now we have a physical interface, 1 PPS. You cannot carry 1 PPS over kilometers, because then you lose the accuracy. Okay? So it has to be close to the client. So this is again how the network look like, and I want to zoom in into different options. So on the right side, you see a case with one client server, and this device using PTP in one case, or it can be also NTP, but then you need the 1 PPS signal. In the middle, we see another case, actually two cases. One of them is just PTP NIC. Then basically you bought a new NIC, and then it's all the way PTP. It's easy, especially if you have a new deployment. Definitely you have to go on this direction. But again, what if you want to maintain your NTP NIC and just use the PTP? One of the options that you can consider is to use like a plug. And this plug can take the PTP flow that is coming into the same device and derive 1 PPS signal out of this and connect the 1 PPS signal into the NTP NIC 1 PPS input. By doing this, you are enhancing the accuracy based on the PTP without replacing the NTP NIC. You maintain the NTP NIC. You can see it later on over there. The last case, this is where you have a location with multiple client servers. Maybe you have 16, maybe you have 32. You have many. Of course, it doesn't make sense to have multiple devices to support the same need. In this case, what you look for, you look for one device that can support many, many clients, because it will be the most cost-effective solution, because how you measure it, you calculate what is the cost per NTP client, and you want to optimize this cost as low as possible. And in this case, if you use multiple clients coming out or supported by one device, by definition, the cost, the additional cost to bring the 1 microsecond accuracy per client would be much better than in any one of the other solutions. So going back to time as a service, but actually it's not just time as a service, is any one of your solution to deliver 1 microsecond. So PTP is great, but PTP without assurance does not bring a value. It's not enough. The networks keep changing. The packet delay variation is changing. The day and night load is different. So now, during the day, you have different packet delay variation overnight. The asymmetry is different. The trick is not just to deliver and forget. This was correct in the old days when we just have to deliver frequency. Today, when we have to deliver 1 microsecond, we need to provide service level agreement. This is the key for any solution like this. Now, if you are going to provide time as a service as operator, what do you need? You need to have the ability to know what is the accuracy that you are providing to your end customers, but because you have to sign SLA with a customer, but at the same time, you know how customers work. They don't trust. They want to know. You want to give the customer the ability to look on his part of the network and see by himself what is the accuracy that the operator provide him. So these are the two sides of the SLA story. The ability of you to assure that you deliver the accuracy, and the ability of your customer to know 24/7, just by one click, what is the accuracy that the operator is providing him. So to summarize, NTP is there, and this is the default solution, and we need to maximize it. So we can upgrade NTP server, NTP v2, NTP v3 to NTP v4, but this would be applicable only if the distance, the number of node distance between the master or the server and the client is very, very short. Combine PTP with NTP, as I explained to you, or do the translation from PTP to NTP. Leverage the investment that already made in PTP in order to improve the accuracy to the NTP without the need to replace the NTP. Of course, if you want to go and buy PTP NICs and replace all your NTP NIC, I'm sure that there will be many vendors. We are not doing any NICs, but there will be many vendors that you love you for this, but it's going to be quite expensive. Sync assurance is the key of this. And before you are going to take a decision how you are going to deliver this, how you are going to implement 1 microsecond for your need, please, I'm proposing, I'm not the operator, you will talk with your operator to see what they have to propose to you. You might find out that this is the most cost-effective solution. Thank you very much.